Welcome back, Helsinki. Thank you. I hope you enjoyed your intermission. Have you done your homework? Oh no, I forgot. All I had to do was think about one thing and I forgot it. Well, the reason why I brought it up is because one of the things that we tend to do, and I'm going to talk a little bit from the heart and also talking on behalf of the organizers of Think Helsinki Think, is that it does feel a little bit kind of crazy and frivolous to have all this technology behind me and all of this other stuff we're talking about when there is a genuine, real, immediate humanitarian crisis in the EU. And for instance, we often think about refugees as something that could happen to us. A refugee might move into our neighborhood. Somebody, 10, 100, 1,000 might move into our town, and they might change things. And we might not have the infrastructure to deal with that, or we might have things that somehow change in our neighborhood, in our lives, because somebody else has had a problem. And the way that the media talks about this often, and the way that some political leaders will talk about this, I think, is not incredibly helpful. Instead of refugee, I think perhaps we should think, say, a person who has no home anymore because they don't have a city, because they don't have a country, because it's gone. If I think about my own family, half of them are from the Scottish descent in Canada, and they're part of the diaspora between the 18th and 19th century of the Highland clearances. People were kicked off their land by the landlords because the agricultural practices changed and people wanted to make more money, so they kicked people off the land. And a lot of people went to Australia, to Canada, to the United States. And there are in fact more people living outside of Scotland now of Scottish descent than there are in Scotland because of that. Or in the 20th century, you have the war children, the sotalapset, from Finland, where 70,000 children were sent to Sweden and to Norway, unattended. We don't let kids be unattended in IKEA. We sent 70,000 of them to strangers. Take care of them, please. We're in danger here. So, if you feel like there's something that you can do, if you feel like there's something you want to think about, I called, for instance, the Red Cross in Helsinki, and they're quite good with donations. They're like, you can donate money, you can donate stuff. They have a lot of stuff. What they really need is people to donate their time and to volunteer. If you look on Facebook, there are some fantastic initiatives, such as one of the refugee centers is near Brahenkenta, where you can play football. So there is a group on Facebook which organizes people together to go and play football with refugees. So it doesn't matter if you don't speak the language, you have a football, everybody gets along. I think it's fine. There's also another one for knitting woolen socks. So as you can see, this is a people's initiative. This is a thing that people can just do. So I urge you not just to think, but also to do. And that's it for the heavy thinking part. And, there are lots of causes, and sometimes it's a little heavy, but hey, we're here to be informed, and we're here to find out exactly what our reality is of our world. And our next speaker is going to talk a little bit about climate change as well in her work, and I'm very excited to introduce, please bring to the stage, Ilona Riipinen.
Good evening. So I thought I'd start the night by challenging you with a little quiz. Everyone likes quizzes, right? So just in case you wonder, this one has been inspired by a recent article in Harvard Business Review. But let's start by imagining that you have a rooftop window and you see a storm is approaching. And the clouds are filling the sky and they are filling your window. And you notice that every minute the area covered by clouds gets doubled. And you also notice that after 48 minutes, your whole window is covered with clouds. No blue sky to be seen. So now my question to you is, how long does it take to cover half of the window? You can think of the answer in your head. You probably have some number. I'm not going to put you in the spot to actually reveal what you think. So the correct answer is 47 minutes, or 1 minute alternatively. So because we have the doubling of the area per every minute, it's during the last minute when you double from half area being covered to the whole window being covered. Okay, if you thought that the correct answer was 24 minutes, so half of the time spent, congratulations, this was wrong answer, but you're not alone. Falsely assuming linearity is actually one of the most common cognitive biases that our brains are sort of hardwired to do, even in the case of exponential relationships between variables, like in this case. So I'm going to talk a little bit about cognitive biases. I'm not an academic expert of cognitive biases or psychology, so everyone who is, forgive me, I'm still going to talk about them, because I'm exposed to them on a daily basis because I'm exposed to my own stupidity. So the other thing that I will talk about today is maybe something that I hopefully know a bit more about, and it's this. So you don't see anything because it's air and we cannot see all the stuff that's in there with our bare eyes, but believe me, there is a lot of things in there. So first of all, there are gas molecules, nitrogen, oxygen, CO2, water vapor. But besides these gas molecules, there are also liquid or solid particles called aerosol particles that are present in this air that we breathe. And that's what my research is mostly about. So what I'm going to talk about today is a combination of some of the topics that interest me, that I want to learn more about. But I will also try to reflect on the part of me that's human, not only a scientist, but also a human. Those cognitive biases, those problems, those issues that I have in trying to understand these phenomena. Okay, so my first example, or first research topic that I'm going to talk about is cloud formation. So how are clouds formed in the atmosphere? Okay, so we have an air parcel where we have water vapor, and we have these small particulate phase chunks called aerosols, which can originate from sea spray, industrial sources, even forests. And then in the atmosphere, if we cool this air, the water vapor will want to start to condense and form liquid or solid particles, cloud droplets or ice crystals. But the energetics of water molecules are such that in the atmospheric conditions, you very rarely get water condensing just as pure water. But instead, to form cloud droplets or to form ice crystals, you need seeds. And these aerosol particles act as seeds for cloud droplets. So if as humans, if we modify the population of the particulate phase matter that's in the air, we also modify the seeds available for cloud droplets to form. Okay, so this is one of my major research topics. And why is it a difficult problem for the human mind to understand? Well, one reason is that in these cloud formation processes, there are a lot of nonlinear phenomena going on. And this we already learned that that's a tricky thing, right? Secondly, the atmosphere is chemically very complex. So there are thousands of different molecular species present in the atmosphere. And this is also known that for the human mind, it's difficult to grasp what the overall behavior of these kind of complex systems actually is. Thirdly, in the cloud formation, many of the physical processes that are happening or involved somehow, like turbulence or ice formation, have a strong stochastic component. And probabilities and stochasticity is also something that's difficult for us to grasp. We tend to kind of falsely assume determinism where it doesn't exist. Okay, so then let's go up a scale a bit. So the other topic that I'm going to talk about today that I find very interesting and that also happens to be very pressing is understanding how different atmospheric components affect the temperature of the Earth, the mean temperature in this case. And this is a graph from the latest IPCC report that compares, this is a simplification that compares the magnitude of different components in terms of how they have warmed or cooled the atmosphere during the industrial period. So that everything that's on the right-hand side is warming, and everything that's on the left-hand side is cooling. So what's been warming the planet? Well, certainly it's not the natural solar variability. That's the second lowermost graph. So it's very small effect, according to the present understanding at least. So the majority of the change in the temperature has been due to different anthropogenic factors that are depicted in the lowermost bar. And in the three uppermost bars, I'm showing now some of the components, some of the major components of the lowermost bar. And as you probably know, the most important warming component has been greenhouse gases, especially carbon dioxide, CO2, from fossil fuels. But besides these warming effects, we have had these particulate matter chunks, aerosols, in the atmosphere, and they have influenced the cloudiness. And the net effect of these particles, these anthropogenically emitted particles, is cooling. So what has happened is that these particles have masked the warming effect of greenhouse gases during the industrial time. And by the way, this is not likely to continue in the future, which is maybe not so good news. But if we look at how the variability in present climate models with respect to these different factors look like, these white bars illustrate that. And what you can see here is that there is quite a large uncertainty, quite a large variability related to the cloud effects on climate. And this variability, of course, then translates into uncertainty in predicting how different actions will affect the Earth's temperature. Okay, so besides the factors that I mentioned when I talked about clouds, one of the extra things that make understanding climate a tricky question is related to just plain scale. So the way that present climate models can simulate, or the scales that present climate models can simulate, are often a lot larger than the scales in which cloud processes happen. Which means that we are actually there limited just by computational capacity to increase the resolution at which we are looking at things. Okay, so what is then needed to solve these problems, to better understand cloud formation and factors governing our climate? Well, in a way, the recipe is simple. We need much more observations. So we need measurements, we need instruments, we need measurement stations in different locations throughout the world, just to observe how the environment behaves, how the atmosphere behaves, what is it made of. But also satellites measuring how the atmosphere interacts with radiation. We also need computers. We need bigger computers, faster computers, computers that can help us overcome these cognitive biases that we have. And then finally, we of course also need people. We'll need smart people who can ask the right questions that are meaningful for the humanity. Okay, so we have a pretty good understanding of what warms the climate, what cools it. We know that if we continue this way that we have, the environment is going to change very fast. But rest assured, I will not be able to tell you what the weather will be like, let's say, 8th of February 2082. How do we deal with this uncertainty then? So here's again the human part of me speaking. I would recommend to use the precautionary principle, so to try to minimize the damage, try to minimize the probability for ending up in a really bad place. And sometimes I actually wonder what's so different between taking care of our health, our body, and taking care of our environment or the globe. I mean, there is a clear analogy. All of us individuals, we only have one body. We only have one life. There's not a lot of room for trial and error. We want to be safe. And very similarly, we actually only have one planet to tamper with. So finally, I would like to encourage all of you to challenge your biases, because we all need to leave this room thinking of new ways of creating more sustainable ways of living. And one of the things we need to think about is, what are the material constraints for a good life in the future? Just looking at it from a physical perspective. We also need to come up with new technological solutions, for instance, developing clean energy. And we need to just accept the fact that the environment is changing fast. It's changing a lot faster than it has in the life of many of our ancestors. And we have to be creative in finding ways to adapt to this. So I actually believe that we can find a more sustainable way of living once the political will is there. And, well, you might think that that's naive, or that this optimism that I have chosen, that this is a bias. Maybe it is. But being human, what are really the options? Thanks.
Yeah, Ilona.